We're going to be interested in the vertex of these parabolas. So we have a form of a parabola called the vertex form. So what happens is we're going to take the standard form of a quadratic and we're going to convert it into the vertex form. And the vertex form is y equals that a value, which tells me if it's going to open upward or downward, parenthesis x minus h squared plus k. So that's my vertex form. And if I have a parabola in this form, the vertex is going to be hk. First of all, how do I know I have a parabola? Because that's squared, and that's what a square tells me my graph is going to be, this parabolic shape. So this is a quadratic, just manipulated in different forms. My A, B, and C from my original standard form are not in the second form. The second form contains the letters h and k. Now if I look at where h is located with x. Therefore, it's going to be my x coordinate. And I can kind of see that k is outside here paired with y. So that's going to be my y coordinate. And there's a special thing about this form that you have to note. The sign is subtract h, and I pick off h. So if this happened to be a plus in that situation, my vertex would be negative h. It's opposite of that sign inside. What we're going to do with this vertex form is we're going to transform it. Transform just means we're going to move it around the coordinate system. We're going to move this graph around the coordinate system. And the first thing we're going to look at is this vertical stretch or compress. Vertical, if you recall, is up and down. So I'm going to stretch this. So if you think silly putty pulling, it stretches it, makes it very narrow. And compressing is going to push down on both ends and kind of squeeze it out the side. So think of silly putty just pulling and making it a long strip, or pushing it down and it kind of plops out the side. So the form for this vertical compression or stretch is going to be y equals a times my function f of x. If you recall, f of x is like a y. So this a value is out with y, and it affects it in the vertical or y direction. So what's happening is we're going to get y equals a times my general form of my quadratic. So taking a look at a graph here, if I want y equals 3x squared, I almost think of that 3 as slope. Rise 3, run 1, it's real narrow. So my parabola is going to be real narrow. Notice I didn't find exact points. That's fine. Opposite of this might be y equals 1/3 x squared. And again, I kind of think of that as a slope, like with a line. So this would be rise 1, run 3. So this would be that compression where it scoots it out the side, where this would be the stretch where it makes it real narrow. So you want to look at where your values are associated and who they are with. A vertical reflection. Let's see, vertical again is up and down. So what I'm going to do is reflect, or we're going to flip up or down. So it's vertical. It's got to have something to do with y. So it's going to be on the y. If you recall, f of x is just a y coordinate. So it says take all of f of x and make it negative, which would flip it down. In a quadratic, it would have a negative value out in front, like that negative a. So it would take my standard y equals x squared, which we call, I like to just call standard. And I'm going to take that, as soon as I put a negative on there, it's going to flop downward. It reflects it up and down. A vertical shift. Well, again, vertical, it must be with y. So it's going to shift it. Let's see, y goes up and down. So it's just going to move my graph up and down. The form says take the y and add some value k. For example, my standard parabola plus k, that's going to shift it up. If I have y equals x squared plus 3, I take my x squared, which normally sits here, that's kind of my parent graph, I need to shift it up 3. So I'm going to take this graph, and it's going to move up to those 3 places. It's just going to shift itself up. So my new graph then would be in this location. Took the same shape, and I just shifted it up 3. Now why 3? Because it says add 3. If I wanted it to be down, I would take this same form, and I would subtract k, and that would move it up or down depending on the sign. Horizontal shift. Horizontal now is not with y anymore, it's with x. So I always like to think about who my shift is with. If it's horizontal, my shift is going to be with my variable x. So the form is y equals f of x minus h. If I had to write out a quadratic, what would it look like? Y equals x minus h squared. Y equals x minus 2 squared. This is going to be a shift with x. Why is it with x? Well, look at where my value is. It's with x. And this shift is going to mean, you need to be careful, it's going to shift it right to. Recall that value of the sign in there. It's a little bit different than if it's outside a parenthesis. So I'm going to shift this right to. So it's my parabola that was normally situated at 0, origin, and I just shifted over 2. So it's just a move left and right depending on the value. Notice it's in with x. So what we want to do is put all of these together. So the first thing I notice is I have a parabola, so I know it's U-shaped. There's nothing with x, meaning it's not shift left or right. There's nothing with y, it's not shifted up or down. The only value I need to think about is this 3. So the vertex is at 0, 0. And the positive 3 tells me it's going to open up because it's in the A position. And if I think slope rise 3, run 1, it's going to be narrow. Notice I didn't think vertical compress or stretch. I just visually thought, rise 3, run 1. So it's going to be fairly narrow. How narrow? I'm not finding exact points. I'm just estimating or providing a sketch. In the second case, again, I have a square, so I know I have a U shape. I have 2 items here. I have the -4 with x and the negative outside. So my vertex then is going to be 4, because that's with x, and there's nothing out here with y. So plotting my vertex, the negative now says my parabola is going to open down. And there's, if you want to think of it, there's a 1 there, so I just call it my standard width. Next scenario, my vertex is a -1, nothing with k. Watch your sign. The 1/2 says I'm going to be up, but I'm going to be pretty wide. Rise 1, run 2 spreads me out. I am not rising, run, and running rise 1, run 2 on my graph per se. It's how I think about that value out in front, slope. And now the last one puts it all together. My vertex, who's with x? Who's out here with y? Watch your sign. So my vertex is at 2, 3. The negative tells me I'm going to open down. That would be your A value. And the 2, let's see, down 2 over 1 is going to produce a fairly narrow graph, down 2. And again, notice I'm just exaggerating that narrow or that width. The big important part is identifying where your vertex is going to be.